Describe the following set as either finite or infinite. The set of all multiples of 4 that are greater than 19. Now we've already discussed this in an earlier problem, but we've already defined the idea of the number of elements in a set, or the cardinal number of the set. But now it's asking about finite or infinite, and those terms are related. Basically, a set is finite if its cardinal number, in other words, this number here, is a whole number, like 5 or 7 or 150 or 10 million, a whole number. Whole numbers are the counting numbers plus 0. It's infinite otherwise. It's a simple idea. If you can associate a whole number to the number of elements in that set, or the cardinal number of that set, then it's finite, otherwise it's infinite. So here they're asking about the multiples of 4 that are greater than 19. So like I said, the whole numbers are the counting numbers plus 0. So you've got to be familiar with this terminology first of all. That would be the set starting with 0 and then the counting numbers 1, 2, 3, 4 and on forever. Now all multiples of 4 that are greater than 19. Well, what is that? Multiples of 4 are 4, 8, 12, 16, 20, 24, keep going. Well, the first one that's greater than 19 would be 20, and then you would have 24, 28, 32, 36, continuing that pattern. So those are the numbers we're talking about. Now obviously you can't assign a whole number. If you started counting those, you would never stop. So you can't assign a whole number to how many there are. So that means that the set is infinite. Let's try another one. This one says we have the set of all y such that y is a number between 7 and 14. We're still answering this question. We want to know whether that set is finite or whether it's infinite. So now we're looking at the numbers between 7 and 14. You have to be really careful here because the word number is very generic. It could be any sort of number. It could be a rational number or an irrational number, a whole number, a negative integer, any number. So 101 over 10 would be right, because 100 divided by 10, if you took 100 divided by 10, you'd get exactly 10. So it's a little bit bigger than 10, so it's obviously in there. So 101 over 10 would be in there. 8 would be in there. 8.1 would be in there. 8.0001 would be in there. 12.99907 would be in there. And you could make these up forever and ever. 13.4 would be in there. So there is no end to this. I could go on. There's no counting all of those. You can't assign a whole number to the cardinal number of this set. So that means this set is also infinite. Let's do one more. This time let's look at the set of all y's. Now these look a lot alike, but it's different. The set of all y's such that y is an integer between 7 and 14. Now whereas the term number is very generic, integer is different. An integer are the counting numbers between 4 and 17. Between 7 and 14. Now it doesn't say between and including 7 and 14, so I would not include 7 nor 14. The numbers, the integers that are strictly between, are the counting numbers between 7 and 14. Remember, the integers are made up of the positive integers, which are the counting numbers, the negative integers, which are the negatives of the counting numbers, and 0. So if you're looking for integers between 7 and 14, now you don't keep going. There are only a few. 8, 9, 10, 11, 12, 13. If you're only looking for integers between 7 and 14, you can assign a cardinal number to that. That's 1, 2, 3, 4, 5, 6. So the number of elements in this set is 6. Since you were able to assign a cardinal number to that, that would be a finite set. So make sure you understand the distinction there. Finite versus infinite.